1000 kg starts from rest position. Clear, ma? The coefficient of friction between the tides and the ground is 0.4. Then find the time the car can cover a distance of 1 kilometer, and what kind of time he is asking? Minimum time. Are you able to understand, ma? Or Chappan. So what is the minimum time in which the car can cover a distance of 1 kilometer? How can I answer this question? It means that less than this time the car cannot cover 1 kilometer. Intakanna takku time lo cover cheyadam sadhyamu avvadu. Are you able to understand? So what is that minimum time in which this car can cover a distance of 1 kilometer? How can I answer? Sima, consider this is the car, and car is starting from rest position, no? Car is starting from rest position. And for the car to move, first of all, it should accelerate, no? Car should accelerate, its velocity should increase. Clear now? Can you say how its velocity is increasing? How its velocity is increasing? Who is applying the force? For a car to accelerate, there should be net force, no? Car accelerate avvali ante net force undali. Who is applying the net force? Can you say? Net force is applied by whom? Chappan. Friction. How friction is applying the net force? It means for car to move, you are saying that friction is responsible. Got it. Yes, sir. No? Okay. So can you say how this friction is responsible for accelerating the car? Here there is no concept of inclined plane. It is moving on a horizontal ground. Sima, when you press the accelerator, tires will start rotating. No? Tires will start rotating. So if this is the tire, if this is the ground. So when tire starts rotating, what is meant by process of rotating? Tire will try to push the ground backwards. That's what it happens, no? What the tire is doing here? Tire is trying to push the road backwards, or it is trying to push the ground backwards. That is called rotating. Sima, how we are able to walk? How we are able to walk, can you say? We are pushing the ground backwards. Ground ne em chestunnam manamu venikki tantu unnam. Then by Newton's third law, what ground will do? Ground will also push us. That is the reason why we are walking forward. So we are able to walk forward only because of friction. If there is no friction, మీ ఊరికే కాలు అల్లాడిస్తూ ఉంటారు కానీ అక్కడే ఉంటారు మీరు. Able to understand? You are pushing the ground backwards. Ground is also pushing you in opposite direction, that is in forward direction. Because ground is pushing you in forward direction, you are able to move. Same concept here also. Tire is rotating. Tire is trying to push the ground backwards. Then by Newton's third law, what ground will do? Ground will push the car forward. Are you able to understand? So car is accelerating only because of friction. Friction lekapothe, if there is no friction, just tires will be rotating continuously, but car will be there only. If there is no friction, how car can move forward? Are you able to understand? So what is the point here? We have to understand point is that the car accelerates only because of what? Only because of friction. Are you able to understand? And he is asking, what kind of time he is asking? Minimum time. Minimum time means what? Very less time. Very less time means what? Acceleration should be maximum. That's the meaning of this one, no? Acceleration is maximum means what? Friction should be maximum. And what is maximum friction called as? Limiting friction. So he is asking us to calculate about limiting friction. Are you able to understand? So let us try to understand. So what he is saying here, time should be minimum, no? Time should be minimum. Time can be minimum only when acceleration is maximum. Okay, ma? Acceleration can be maximum only when friction is maximum. Because friction is the force which is pushing the car forward, no? Friction should be maximum. Clear? And what is maximum friction called as? So this friction we can call it as limiting friction. Already we have studied, no? Maximum value of friction is called as limiting friction. Okay. Now in this condition, can you say, how can I calculate limiting friction? What is the formula of limiting friction? Mu s into n. Clear, no? Mu s value 0.4. Normal reaction. Normal reaction. Normal reaction. Normal reaction is nothing but weight only, no, in this condition. Weight of the car will fall on the ground. What is the weight formula? mg, mass is 1000, g value is 10. So 10,000 newtons is the weight of this body. So this weight falls on the ground. What ground will do? Ground will give a normal reaction. So normal reaction also will be exactly equal to 10,000 newton. Clear now? So substitute here. So 10,000 newton. Okay. So 0.4 into 10,000 is 4,000 newton will be the limiting friction. Are you able to understand now? Now, what this limiting friction will do? వినాలి చెప్పేటప్పుడు వినాలి, రాయటానికి కాదు మనం వచ్చేది, అర్థం చేసుకోవడానికి. Are you able to understand? I will give you time for writing, don't worry. Okay. Now can you say what this limiting friction is doing, ma? This is the force which is pushing the car in forward direction. It means this limiting friction is providing net force. Net force formula? Mass into acceleration. That's all. No? So therefore I say limiting friction is nothing but net force. Net force is equal to mass into acceleration. Clear? So what is the net force? Net force is 4,000. Mass of the car is 1,000 and acceleration is a. So therefore what is the acceleration value? 4 meter per second square. Are you able to understand me? So what do you understand by 4 meter per second square? 4 meter per second square ante? So on this ground, car can accelerate only with an acceleration of 4 meter per second square. Maximum acceleration. ఇంతకన్నా మీరు యాక్సిలరేషన్ ఎంత తొక్కినా ఇంతకన్నా కారు యాక్సిలరేట్ అవ్వదు. ఆర్ ఏబుల్ టు అండర్స్టాండ్? లెట్ ఇట్ బి మారుతి 800 డబ్బా కార్ ఆర్ లెట్ ఇట్ బి ల్యాంబోర్గిని. ఆర్ ఏబుల్ టు అండర్స్టాండ్? ఎనీ కార్ కెనాట్ యాక్సిలరేట్ విత్ దిస్ మచ్ ఆఫ్ యాక్సిలరేషన్ ఇన్ దిస్ గివెన్ కండిషన్, because acceleration is depending on what? Friction. And friction cannot be unlimited. No. Friction cannot be unlimited. Friction always is having only certain value, limiting friction. And who is responsible for accelerating this car? Only friction. Are you able to understand? Friction is always limited. So acceleration is also limited. So more than this acceleration, this particular mass of the car, and for this coefficient of friction, car cannot accelerate. అది ఏ కార్ అయినా సరే ఇంతకు మించి యాక్సిలేట్ అవ్వలేదు. ఏ కండిషన్లో? మాస్ షుడ్ బి 1000 అండ్ కోఎఫిషియంట్ ఆఫ్ ఫ్రిక్షన్ షుడ్ బి 0.4, because limiting friction depends on only these two factors. No? Okay. So therefore, once I calculated acceleration, now can't I calculate what is the time traveled or time taken to cover 1 kilometer? Which equation I can use? I can use the relation of kinematics. S is equals to ut plus half at square. That's all. No? So displacement is 1 kilometer. 1 kilometer means 1000 meters. Initial velocity 0. Half. Acceleration 4. Time taken I don't know. So 2 ones are 2 2s are, so 5000. So t square is equals to 500. So t is equals to root 500 seconds. That's all. No? So this is the minimum time in which car can cover 1 kilometer. Clear? No? Less than this time car cannot cover, whatever may be the force you apply on the car, whatever may be the what you call power of the engine. So less than this time car cannot cover. Are you able to understand? That's it. Make a note. This is the given question. So 10 kg body present on a surface whose coefficient of friction is 0.1. We are applying a force of 100 Newton at an angle of 37 degrees. Clear number? So we are not applying force horizontally, we are not applying the force vertically also. We are applying the force at an angle of 37 degrees with respect to vertical. Clear? Then these are the three questions which you are supposed to answer. So what is the normal reaction, limiting friction and acceleration of this mass? Okay? Come on. Can anybody suggest me how can I proceed in this problem? Splitting. Okay, so let us split this force into two components. So this force is making how much angle? It is making an angle of 37 degrees. Clear now? So this is 100 Newton. So adjacent side will be how much? 100 cos 37. Opposite side 100 sin 37. So 100 cos 37 value 4 by 5. So 5 ones are 5 20s are 80 Newton. So 100 sin 37 3 by 5. So 23s are 16 Newton. That's all now. So this force of 100 Newton, I have split into horizontal force of 60 Newton and vertical force of 80 Newton. Clear now? Now let us draw the free body diagram of this 10 kg body. Clear now? Free body diagram of 10 kg body. Clear now? So therefore, on this 10 kg body, now can you say how many forces are acting? First of all, its own weight will be acting, no? What will be the weight of this body? 100 Newton. Still? Normal reaction. How much is the normal reaction? I don't know. Clear now? In this condition, I don't know what is the normal reaction. Why I don't know the normal reaction? Because there is one more force which is pushing the body downwards, no? One force is pushing the body downwards. So normal reaction is no longer 100 Newton here. Ippudu normal reaction 100 Newton kaadu. Previous conditions it was fine. Are you able to understand? Now let us see. So 60 Newton is pulling the body in this direction now. This 60 Newton is pulling the body in this direction. Similarly, we have one more component 80 Newton. No? What this 80 Newton is doing? 80 Newton is pushing this body downwards. Clear? And if body tries to move in this direction, friction will start acting in opposite direction. So these are the different forces which are acting on this body. Are there any other forces? No. These are the different forces which are acting. Are you able to understand, ma? Okay. Now we will study the forces along x-axis and we will study the forces along y-axis. Okay, ma? So along x-axis, first of all we will take along y-axis. Now along y-axis, can you say what are the forces which are acting? 100 Newton, 80 Newton, normal reaction. Now can you say what is the relation between them?
180 minus.
180 minus. Yeah, 180 minus. 180 minus n is equal to 0. Very good. అంత లాజిక్ ఎందుకు సింపుల్గా మీరు చెప్పచ్చు. సిమ్ అప్వర్డ్ ఫోర్సెస్ అండ్ డౌన్వర్డ్ ఫోర్సెస్ దే మస్ట్ బి బ్యాలెన్స్డ్, నో? అప్వర్డ్ ఫోర్సెస్ అండ్ డౌన్వర్డ్ ఫోర్సెస్ మస్ట్ బి బ్యాలెన్స్డ్. వై దే షుడ్ బి బ్యాలెన్స్డ్? బికాస్ దిస్ బాడీ ఈజ్ ఇట్ మూవింగ్ అప్వర్డ్స్? పైకి వెళ్తుందా ఇది? నో. కిందికి వెళ్తుందా? లేదు. అంటే ఫోర్సెస్ విచ్ ఆర్ యాక్టింగ్ అలాంగ్ వై యాక్సిస్ దే మస్ట్ బి బ్యాలెన్స్డ్ విత్ ఈచ్ అదర్. వాట్ ఈస్ ద ఫోర్స్ విచ్ ఈస్ యాక్టింగ్ ఇన్ అప్వర్డ్ డైరెక్షన్? Normal reaction. Forces acting in downward direction? 80 and 100. So therefore normal reaction is equals to 80 plus 100. Like this also you can see. So I calculated the normal reaction. Are you able to understand? See, in this condition, normal reaction is no longer 100. Normal reaction is how much? 180 plus 100. 100 plus 80. Are you able to understand now? Okay. So I have calculated the answer for the first one. Okay. Next, second one. Limiting friction. Formula for limiting friction? Mu s into L. Mu s value? 0.1. Normal reaction? 180. So total how much? 80 Newton is the limiting friction. Second answer also I have calculated now. Okay. Now third question. What is the acceleration of the mass? Acceleration, how can I calculate? Formula for acceleration? Acceleration formula. A is equals to net force divided by mass of the body. Net force is how much?
40.
Net force. So what is the force which is acting in this direction? 60. 60 is trying to pull the body, no? Then which is the opposing force? Limiting friction is the opposing force. What is the limiting friction? Limiting friction is 80. So therefore what is the net force?
42.
42. How you got this 42? 60 minus 18 divided by what is the mass of the body? 10 kg. So therefore what is the acceleration, ma? 42 divided by 10, which is equal to 4.2 meter per second square. That is our acceleration. Understood, no? Come on. చూడకుండా చేయండి ఒకసారి. Question, ma? So 10 kg body, 6 kg body, and on this 10 kg body I am placing a mass of m. Okay, ma? So coefficient of friction between this 10 kg body and this ground is 1/3. Then what is the mass small m I have to place on this 10 kg body such that this system does not move? System slide అవ్వకుండా ఉండాలంటే ఈ మాస్ యొక్క మాస్ ఎంత ఉండాలి? That is the question. Come on. Anybody, can you see? So I want 10 kg body doesn't move. Okay. Then what is the mass small m I have to place on 10 kg body? Any idea? Sima, here system should be in rest, no? System should be at rest position. Clear now? If a system should be at rest position, what is the acceleration? Acceleration is 0. That's the meaning of this one. If total system is in rest position, acceleration will be 0. Okay. So if acceleration is 0, now if you take this body, this is the body which is responsible for pulling the system downwards now. This is the force which is responsible for pulling the body downwards. Clear now? What is the weight of this body? 60 Newton. Then tension should be how much? Tension should be how much? 60 only, because acceleration is 0, no? This is 6 kg body, it is not coming downwards or it is not moving upwards. It is accelerating downwards, 60 should be greater than T. If it is accelerating upwards, tension should be greater than 60. But system is not moving, no? It means that tension and weight, they should be balanced with each other. These are the only two forces which are acting on the 6 kg body now. One is a tension, another one is 60 Newton. So therefore what I say, tension must be equal to 60 Newton. Are you able to understand? Clear now? Now same tension is pulling this total 10 kg and mass also in this direction. Always we studied tension is a double-sided force now. Tension is always a double-sided force. Always it acts in two directions but in opposite direction. Are you able to understand? And what is the direction of tension? Away from the right end. Kattesina vaipu nunchi bayatuku undali. Are you able to understand? So this is the tension, and what is the magnitude of tension? 60 Newton. Same 60 Newton is pulling this system in this direction. That's all. But why this system is not moving? Because in opposite direction, definitely same amount of friction also must be acting. Clear now? Tension is pulling 10 kg body and mass m, but they are not moving. They are not moving means what? Definitely an equal and opposite force should have been acting in opposite direction. And what is that force? That force is exactly 60 Newton, and that should have been provided by friction itself. Are you able to understand? Okay. Now, so therefore friction value, how can I calculate now? Let us call that friction to be FL, limiting friction. Limiting friction is 60 Newton. Are you able to understand? So limiting friction formula, mu s into n. So mu s value 1 by 3. Normal reaction is how much? 100 plus 10. Very good, excellent. Or just I can write 10 plus m into g, no? I can write like this also. Clear? Total mass is 10 plus m. Mass multiplied by g value will become weight of the body. Are you able to understand? So this weight is falling on the ground. Ground will give an equal normal reaction. So what is the normal reaction? Normal reaction is total mass 10 plus m multiplied by g value. Are you able to understand? Now what is the only unknown quantity here? Only unknown quantity is mass only, no? So just calculate that mass. Clear number? So therefore 6 3s are 180. 180 is equals to 10 plus m multiplied by g value is 10. So 10 and 0 get cancelled. So therefore what is the mass of the body? 18 minus 10, it is equals to 8 kg. Okay. So what is the minimum mass I have to place? Minimum mass is 8 kg. If I place 9 kg, 8 బదులు 9 kg ప్లేస్ చేస్తే ఏమవుతుంది? Minimum, this is what kind of mass? Minimum mass. Minimum should be 8 kg. If I place 9 kg, what will happen? ఆశిష్ బుక్ కొనుక్కోవడానికి 20 రూపాయలు కావాలి. 25 ఇచ్చిన ఏమవుతుంది? హ్యాపీగా బుక్ కొనుక్కుంటాడు, 5 రూపాయలతో చాక్లెట్ కూడా కొనుక్కుంటాడు. దట్స్ ఆల్ అమ్మా. ఐ రిక్వైర్ ఓన్లీ 8 kg body. If I am placing 9 kg body, no problem, system will be in rest position. If I place 10 kg, system will be in rest position. 20 kg, system will be in rest position. 7 kg, body cannot be in rest position. Are you able to understand, ma? If I place 8 kg body, then only limiting friction will be active. Are you able to understand, ma? It means just if I apply 61 Newton, 60 badalu, if I apply 61 Newton, system will slide. System will slide, because what is the limiting friction we have considered? 60 Newton. But if I place a 9 kg body, limiting friction also increases and system will be happily in rest position. Are you able to understand? For example, if I place a 9 kg body, then what is the limiting friction? पहले biology class on करो. Clear ma? So what were we discussing? If I place a 9 kg body, for example, if mass is 9 kg, then what is the limiting friction? Limiting friction is 10 plus 9, 19. 19 only, no? 19 into coefficient of friction, 1 by 3. Clear now? So therefore, what is the 19 by 3 is how much? Into G, I forgot. No? So, into 10 into 1 by 3. So, 190 by 3. 6 3s are 18, no? Ma? So, 63 Newton, approximately. 63.3 Newton. Are you able to understand? So, then limiting friction, but what is the tension I require? Tension applied is only 60. But a limiting friction is how much? 63. So therefore, the friction applied will not be limiting friction. It will be just a friction, that's all. Are you able to understand? If I place 9 kg body, friction has not reached maximum value. Because friction will reach maximum value only when applied force is maximum. I am applying how much force? Only 60. So limiting friction, friction will be how much? 60 only. But limiting friction is how much? 63. If I place 9 kg body. Are you able to understand? So that's why I am not placing 9 kg body. I require only minimum mass. And what is the minimum mass? 8 kg body. If I place 8 kg body, then limiting friction is also 60. Applied force is also 60. Then the system is ready to slide. Slide avvataniki ready ga undi. But it is not sliding. Are you able to understand? That is the condition. Come on. Okay. So already I explained you in the previous concept only, Nama. If you have any doubt, again you go to the same video lecture and watch it once again. Clear, no? So friction is a self-adjusting force. Friction is what kind of force, ma? Self-adjusting force. If you start applying force on a body, friction also starts developing in opposite direction. Okay? If you don't apply any force on a body, friction also will not be there. Okay? And friction cannot be unlimited. It is always limited. These are the points which we discussed now. That's it. So therefore, here what is the minimum mass I have to place, ma? Minimum mass is 8 kg. More than 8 kg if you want to place, no problem. Okay, ma? See, ma, this is the given question. So on this ground there is a body of mass m. To this mass m we are tying a rope. Rope is passing through 3 pulleys and same rope is held by the man. Mass of the man is capital M. Clear, number? Then what is the maximum force the person can pull this rope such that this mass is in rest position? Total system rest lone undali. If that means this board, it should not slide on the ground. Clear, number? Then what is the maximum force this person can apply on this rope? That is the question. Clear, number? So can you say how can I proceed in this problem? System is in rest position means what once again? System is at rest position. So it means acceleration is 0. Acceleration is 0 means all the net forces acting are 0. There is no net force. Clear, no? So here two bodies are there, number. One is the man and one is the block or the board. So draw the free body diagrams of both of them. So free body diagram of man. Are you able to understand? No? So on the man, how many forces are acting? First of all, his own weight, capital mg, will be acting in downwards direction. No? Okay, and his total weight is not falling on the platform. What is total weight to platform paina padutu unda? No. Why? Because he is holding the rope. No? Rope ni kindiki lagutu unnadu kada. So rope is also pulling him in upward direction. So it means that his total weight is not falling on the board. If he stands still without holding anything, then his total weight will fall on the ground. But he is holding something, no? That something is also pulling him in upward direction. Are you able to understand? No? So therefore, only some of his weight falls on the ground. And then what this small m will do? Small m will give an equal amount of normal reaction. And what is that normal reaction? Still I don't know. Are you able to understand? Ma? So this is the reaction. Weight, some weight of the man falling on the board is the action. Board giving a reaction, board giving normal reaction is the reaction. Are you able to understand? Okay. So still any other forces on the man? Still any other forces on the man? Man is pulling the rope downwards. No? Then what rope is doing? Rope is pulling the man in upwards direction. So one more force which is acting is tension in the rope. Okay, ma? Now let us see what are the directions of tension. Same tension is acting throughout this rope, no ma? Same tension is acting throughout this rope. So here also tension will be T only, and here also tension will be T only, here also tension will be T only. Everywhere same tension. Because all the ropes we are considering massless ropes. And in massless ropes, tension will be same everywhere. Are you able to understand? Okay. So this is the free body diagram of the man. Now how can you write a relation between them? So N plus T is equal to capital mg. This is my first equation. Because all the forces they are balanced, upward forces and downward forces are balanced with each other. Clear? Then let us draw the free body diagram of mass. This board. Okay. Now on this board, how many forces are acting? Can you see? Wait, how much? Small mg. Still? Sum of the weight of the man, which I call it as normal reaction. Total weight is not falling, no? Only some weight is falling, that is normal reaction. And same reaction is given by the board also. Okay, ma? So this N is the action, this N is the reaction. Are you able to understand? Still? Tension. Tension in which direction? Tension in horizontal direction. T kasu. Enduka kasu saino? Tension is already horizontal, no? You need not split that. Okay, still? Friction. Friction will be acting in which direction? Opposite direction. Sima. If tension tries to pull this body in this direction, friction will develop in opposite direction. And he is asking maximum force. Maximum force means what? Block is ready to slide. That is the meaning of this one, no? Block slide avvataniki ready ga undi. It means the friction is limiting friction. Friction has already reached the maximum value. Where friction already reaches the maximum value, then only body will be ready to slide, no? Are you able to understand, no? So therefore what I say, therefore, the friction which is developed is already maximum, and that is called as limiting friction. Are you able to understand? Then any other forces? Some more force is N dash is also present, Nama. So, see, normal reaction and mg, they are the forces which are pulling this mass downwards. So this total force, it falls on the ground. Ground will give a normal reaction N dash. So these are the different forces. Are you able to understand? Now again you balance all of them. Now see what are the forces along x-axis, tension and Fl. Clear now? So similarly along y-axis, N dash is equals to N plus mg. Are you able to understand now? So these are the forces along x-axis and these are the forces along y-axis. Okay. Now by using all these forces, what I am supposed to calculate? I am supposed to calculate T. What is T? Tension developed in the rope. Why tension has developed in the rope? Because man is pushing the rope. So force applied by the man and tension both are same. He is asking force applied by the man only, no? Because of force applied by the man only, tension has developed. So force applied by the man and tension both are same. So calculate T value, that is my answer. Okay, come on. Brain. Okay. ఎంత ప్రెషర్ పెడతారో అది అంత షార్ప్ అవుతుంది అన్నమాట. Okay. See ma here, three equations we have derived now. This is the second equation and this is the third equation. So how many unknown quantities I have? N is an unknown quantity. T is also unknown quantity. N dash is also unknown quantity. Okay. Three unknown quantities are there, three equations are there. Definitely I can do the problem now. Okay, let us see. So therefore, let us see how we can proceed in this problem. See my first one, T is equal to Fl. Fl can be written as mu into N dash, no? Why I am writing mu into N dash here? Because on this mass, what is the total normal reaction which is acting? Total normal reaction is not N, it is N dash. Are you able to understand? No? So N is the normal reaction acting on the man. N dash is the normal reaction acting on the mass. Are you able to understand? So mu into N dash. N dash value already I have calculated, no? Substitute here. So therefore T is equals to mu into N dash value. N dash value is N plus mg. Clear now? Now let us call this equation as equation number 4. Now you see equation number 1 and equation number 4. Only two unknown quantities are there, no? T is one unknown quantity, N is also unknown quantity. Two unknown quantities, two equations. Now you can solve very easily. Clear now? What I want actually? I want a T. So therefore take this N value, capital Mg minus T. Take this N value, substitute here. Clear now? So therefore T is equals to mu into mg minus T plus small mg. Clear now? So therefore now changing ikkada nunchi. Clear now? So T is equals to mu capital Mg minus mu T plus mu small mg. Clear now? So all T terms if I take on one side, mu plus 1 is equals to mu if I take common or mu g if I take common, then it is capital M plus small m. Are able to understand? So therefore T is equals to mu g into capital M plus small m divided by mu plus 1. So this is my answer. Are able to understand? So this is how we have done this calculation. So what is meant by T here? T is the tension acting in the rope. Clear now? Tension is nothing but force applied by the man on the rope. And this is what kind of force? Maximum force. Why force is maximum? Because body is ready to slide. Why body is ready to slide? Because friction, we have taken limiting friction. Clear now? If I apply force greater than FL, then body will slide. Are you able to understand? That's very simple. Come. Okay, ma, this is the question. Body of mass M is supported to this vertical wall. Clear now? And the coefficient of friction between vertical wall and mass capital M is mu. So if I release this mass, what will happen? It will fall to the ground now. But I don't want this mass to fall down. So I am applying a force of F at an angle of theta. Now there will be a range of forces, a set of forces which I can apply so that this body doesn't fall down. So what is that maximum force and what is that minimum force I can apply such that this mass does not fall down? That is the question. Able to understand? So not only one force, a range of force, a set of forces I can apply so that this mass doesn't fall down. How can we calculate that set of forces? First of all, can you say how can I proceed? చెప్పండి జ్వరం నాకు వచ్చింది మీకు చెప్పొచ్చు గట్టిగా మేక్ ఇట్ ఫాస్ట్. సో first of all, what I can do, I can split this force into two components because this force is not horizontal, this force is not vertical no more. So first of all, you split this one into two components. So this is the applied force F. Clear now? So if this angle is theta, then what will be this angle? This angle also will be theta only, no? Clear? So therefore what I can do, this force I can split into two components. Clear now? So this is F cos theta and this one is F sin theta. First of all, we have done this thing. Then let us draw the free body diagram of this free body diagram, or let us do one thing. Free body diagram of mass if minimum force is applied. Minimum force is applied. Clear? So how can I draw the free body diagram if minimum force is applied? Clear? So can you say what is meant by minimum force is applied? Very less amount of force I am applying so that this body doesn't fall down. Okay. Can you explain what is meant by minimum force? Minimum force condition ante mani, maximum force condition ante mani. Minimum force means so it means you are saying we are applying very little force. So why you are applying little force? In which condition? See, minimum force means this body will try to fall down. No? This body will try to fall down. I will apply minimum force such that this body doesn't fall down. So body is trying to come downwards. Body is trying to come downwards. If a body tries to come downwards, friction will act in which direction? Friction will act in upwards direction. And it means friction is also supporting the body. And friction should be maximum. Then only my applied force will be minimum. So ikkada support evaru istunaru, friction is also supporting the body. Are you able to understand? So body is trying to come downwards, but friction is opposing the motion of the body, and definitely weight of the body will be greater than friction. No? Weight of the body will be greater than friction. So that extra force I am supplying so that body doesn't fall down. Are you able to understand? It means minimum force means what? Body is trying to come. Body is trying to fall downwards. This is called as condition of minimum force. Are you able to understand? Now let us draw the free body diagram of this one. If this is the body of mass capital M, okay, ma? How many forces are there? Already I have split this one into two components, no? F cos theta and F sin theta. Clear, no? F cos theta is acting in this direction. So this is the direction of F cos theta. Clear, no? F sin theta is acting in which direction? F sin theta is acting in this direction. Are you able to understand, no? One weight of the body, capital Mg, will be acting in downwards direction. Okay? Still any other force? When body is trying to fall downwards, friction will start acting in upwards direction. And friction should be maximum. So maximum support every volley, friction. Then only my applied force will be minimum. Ante kada? Friction maximum support istundante nenu apply chesina force minimum. So, and what is the maximum friction called as? Limiting friction. Are you able to understand? Okay. And there is one more force. Can you say what is that? One more force. Huh? Normal reaction between what and what? Box and wall. See, I am pushing the box or I am pushing this body with a force of F sin theta. So this body goes and pushes the wall. Then what wall will do? Wall will give an equal amount of normal reaction. Okay? ఎక్కువ కామన్ సెన్స్ ఉంది ఫిజిక్స్ కన్నా కూడా. ఫిజిక్సే కామన్ సెన్స్. ఎనర్జీనే లైటే ఎనర్జీ అన్నట్లు కామన్ సెన్సే ఫిజిక్స్, ఫిజిక్సే కామన్ సెన్స్. Okay? So these are the different forces which are acting now. Body is trying to come downwards. I am applying a minimum force of F cos theta so that body doesn't fall down. So body is trying to fall downwards. That's why friction is acting in upwards direction. It means the friction is also holding the body. Friction is also holding the body such that the body doesn't fall down. And we are pushing this body with a force of F sin theta. Therefore, normal reaction is also F sin theta. Are you able to understand now? Now, all the system, all the body, it is in rest position. No? Rest means what again? Acceleration is zero. Acceleration is zero means what? All the net forces acting are zero. Net forces are acting are zero means what? Net force along x-axis is also zero. Net force along y-axis is also zero. All the forces along x-axis and y-axis, they are getting balanced with each other. Clear now? Now if I take along x-axis, how many forces are acting along x-axis? Along x-axis, how many forces are acting? Huh? One force is normal reaction, another force is F sin theta. They are equal now, and they should be opposite also. So therefore what I can say normal reaction is nothing but F sin theta. So this is my first equation. Clear now? Now what are the forces which are acting along y-axis? Along y-axis, what are the forces which are acting? See, my F cos theta and Fl, both of them, they are pulling the body upwards. And which is the force which is pulling the body downwards? Mg. So your applied force in vertical direction and limiting friction, they are responsible for supporting the body. And they are balancing the weight of the body, capital Mg. That's all. So therefore I say F cos theta plus Fl is equal to capital Mg. That's all. And what is the formula for limiting friction? Mu s into n, substitute here. So F cos theta plus mu s into n, normal reaction already I have calculated now, F sin theta is equal to capital Mg. That's all. Now here what is the only unknown quantity? F. F is the only unknown quantity, no? Remaining all values are. So just derive that F value. That is my required answer for minimum force. Are you able to understand? Come on, do it. So try to do this calculation without seeing on the board. Roughly ఒకసారి చూడకుండా చేయండి. Then you copy this one from the board. Clear, ma? Therefore, I will do the calculation here. So therefore, F if I take common, then it is cos theta plus mu s sin theta is equal to capital Mg. So therefore, F is equal to Mg divided by cos theta plus mu s sin theta. Clear now? So this is my equation for minimum force which I can apply so that this body doesn't fall down. Clear now? Now calculate maximum force. What is meant by maximum force? So minimum, if I supply this much force, body will be in rest position. If I apply a force greater than this force, nothing will happen. Until I reach maximum force, body doesn't move. So what do you understand by maximum force? Maximum force means? Chapandi. Limiting friction? Maximum force means what? ఆలోచించండి. ఇఫ్ ఐ అప్లై ఫోర్స్ మోర్ దాన్ దిస్ ఫోర్స్, దెన్ వాట్ స్టార్ట్స్ హ్యాపెనింగ్? Friction direction changes. That's all. No? So if I apply force greater than this force, continuously applying the force in upward direction, then body will try to slide in upwards direction. No? Body will try to slide in upwards direction if you apply force greater than certain limit. Clear now? If a body tries to slide in upwards direction, friction will act in which direction? Downwards direction. And what is the maximum friction? FL. FL. No? So it means if you apply force greater than FL, then body will slide upwards. So therefore, what is your maximum force? Your maximum force should be such that FL has developed and body is ready to slide upwards. Body is ready to slide upwards. You should apply only that much of force. If you apply greater than that force, body will slide upwards. But I doesn't want body to slide upwards. So apply only that much force where FL is acting in downwards direction, and FL means already maximum friction. That's it. Okay, ma? That's all. So draw the new free body diagram and see what is the answer you will get. Okay, come on. So free body diagram, if F max is applied in, if F max is applied, it means the body is trying to move in upwards direction. Clear now? It means previously we have written FL in upward direction, no? Now we are writing FL in downwards direction. It means if I apply a force greater than this F cos theta, body will move in upwards direction. Clear now? Now body is not moving, it is ready to move. So therefore again all the forces they are balanced, no? So therefore what I can write? Again same conditions will be satisfied. Along x-axis n is equal to f sin theta, this is also satisfied. The only equation which is not satisfied is mg and fl, they are acting in downwards direction. So this fl I will send to this side. Clear now? F cos theta is the supporting force. Now f cos theta should support these two forces now. It should support mg also, it should support limiting friction also. So definitely my applied force should be greater, no? Are you able to understand? So therefore now do the calculation. There is nothing here. Just do the calculation. Clear now? So therefore f cos theta minus fl is equal to capital mg. Clear now? So f cos theta minus fl mu s into n is equal to capital mg. So f cos theta minus mu s into normal reaction is f sin theta is equal to capital mg. Clear now? So f, if I take common, cos theta minus mu s sin theta is equal to capital mg. So therefore f is equal to mg divided by cos theta minus mu s sin theta. So this is my answer. Okay. So what is the difference between previous condition and this condition, ma? Previous condition we got cos theta plus mu s sin theta, but here we got cos theta minus mu s sin theta. That is the only difference. Clear? Very simple. Okay, ma? So typical NEET level and mains level questions. Ante, very easy. Just if you understand the concept very carefully, you can solve the problem within 20 to 30 seconds. That's it. Okay.